What is going on YouTube and AP Chem students? My name is Paul. In this chemistry, today we're going to be learning how to convert from molecules and atoms to moles and moles to molecules and atoms. The conversion is significant to chemistry because it tells us how many atoms or molecules are in a specific amount of moles.
First off, we need to understand the relationship between moles and Avogadro's constant. It holds that 1 mole of a substance equals 6.022 times 10 to the 23rd molecules. And we're back! So this is our first problem, and it says how many molecules in 5 moles of H2O. So we know this relationship where 6.022 times 10 to the 23rd molecules is equal to 1 mole. So we can simply take 5 moles of H2O, multiply it by the constant, and we get 4 times 10 to the 24th molecules. Who's this?
Are you ready for chemistry?
Do you like chemistry?
Swag! In some cases, you'll be required to find the number of atoms in an element in a compound. Oh, look at the question! If we have 5 moles of H2O, how many hydrogen atoms are in the sample? We start out with 5 moles of water. However, we have to convert this, acknowledging that there are 2 hydrogen atoms per molecule of water, so we multiply 5 moles by 2. Then we have to convert this to atoms, so we multiply by Avogadro's number, and we get 6.022 times 10 to the 24th atoms of hydrogen, which is 6 times 10 to the 24th atoms in significant figures.
So it doesn't matter what compound you're using. You can use the same idea where you multiply the subscript of the element you're trying to find by the total number of moles, and then you multiply that by Avogadro's number. So if you're trying to find hydrogen, for example, in this, you take 12, multiply it by 5, and then the constant, and then you get the number of atoms for hydrogen.
Converting from atoms to moles instead is the same process, just flipped around. First, we start out with 5 times 10 to the 25th hydrogen atoms in H2O. We have to account for how many hydrogen atoms are in a water molecule, so we divide by 2. This is just taking the process backwards. Then we divide by Avogadro's number, 6.022 times 10 to the 23rd molecules per mole, and we end up with 41.5 moles of H2O, and in significant figures, this is 40 moles of water. Bye-bye!
Wait, Paul! You forgot your cheat sheet!
How does this work?
Okay, so if you're going from moles to molecules, you take the number of moles, multiply it by Avogadro's number. From moles to atoms of a compound, you take moles times the subscript of your desired element, and then times Avogadro's number. If you're going from atoms in the compound to moles, you go from the atoms of element in compound divided by the atoms per molecule, or the subscript, and then you divide that by Avogadro's number.
Thank you.